A 0.4 kilogram mass. So this is the 0.4 kilogram mass when dropped from a certain height. So this height, this complete height here is P at t is equal to 0 dropped, which means the initial velocity should be equal to 0, right? Above the surface of the earth, P. So I've considered this blue line here to be the surface of the earth. The loss of potential energy in the last second of fall is. See, how many seconds will it take to reach the bottom, the surface of the earth? It is 8 seconds. So this line here represents distance traveled in 8 seconds or height traveled in 8 seconds. So what does it mean in the last second? Last second means distance traveled in the last second means distance traveled in 8 seconds minus distance traveled in 7 seconds. So basically, we've been asked to find out this much distance traveled in the last second. And how will you do that? Basic geometry. You have this complete distance here, right? So if I were to draw like, so if you subtract this much distance, right? So maybe I can write it as A, B, and then CD. If you subtract CD from AB, what do you get? What you get is distance traveled in the last second. And how can you do that? We have the direct formula for this. Displacement in the nth second is equal to u plus g by 2 into 2n minus 1. And if we were to apply that, what do we get? Displacement in nth second is, so since the total distance, sorry, since the motion was totally for 8 seconds, we have n is equal to 8 seconds, the last second is equal to n is equal to 8. Since it has dropped, we have u is equal to 0. G by 2 is 10 by 2, 2 into 8 minus 1, 16 minus 1 is 15, 10 by 2 is 5, 15 to 5 is 75. Now, it means that the distance traveled in the last second is 75 meters. Now, what will be change in potential energy? Change in potential energy in the last second to be important. Change in potential energy in the last second would be equal to delta u, which is equal to m into g into distance in the last second, which is 75. 75 into 4 is 300 into, sorry, 75 into 0.4 into 10 is 300 joules. Now if you want to do it in a very detailed way, then we can make use of the complete calculation, which would go like this, right? Using kinematic equations of motion. What is S is equal to ut plus half at square. Since the motion is taking place in a vertical direction, we can write that Sy is equal to uy into t plus half ay into t square. Now, since this object is falling from rest, what will be the acceleration direction? I'm sorry, what will be the direction of acceleration due to gravity? How would you take it as? We'll take the magnitude as positive g, right? And therefore, this equation can be reframed as Sy is equal to, dropped from rest, this will become 0. This will be written as plus Ay can be written as plus g by 2 into what? Into t square. And this is Sy. So first we'll find out S at 8. What is S at 8? S at 8 will be equal to g by 2, I'll write it as 5, 10 by 2, 5, into t square, which is 8 square. 8 square is 64, and then we have 64 into 5, 5 4 so 20, 320, right? And what is S7? S7 will be distance fallen in the first 7 seconds, which will be equal to 0 plus g by 2, which is 5 into 7 square. 7 square is 30. 7 square is 49. So we have 49 into 5. 9 5s are 45, 5 4 so 20 plus 4, 24. So we have 245, right? Now, what is distance fallen in the last second? It will be distance traveled in the 8 seconds minus distance traveled in the 7 seconds, which would be equal to 320 minus 245. So we got 320 minus 245, which is 75, right? So this would be equal to 75 meter. And what is the loss of potential energy in the last second? It will be equal to mass into acceleration into gravity into distance fallen in the last second, which is equal to 75. And we get the same answer again, m into g into 75 meter. The correct answer being, okay, what was the mass? The mass is 0.4 into g is 10 into 75 is 300. Okay, very straightforward question. You can do it in, that depends upon you to choose the shortest way or to go for I think being a JEE main exam, you should be able to in the first formula itself, right, directly get the answer. Okay, let's now move on to the next question. This was a relatively very simple question. Moving on to the next one now.